All right, today we're jumping right into a problem that every single support engineer has dealt with, that dreaded slow query. We're going to show you how to use the completely free tools inside MySQL Workbench so you can go from just a vague user complaint to diagnosing the problem like a real DBA.
You know the one. It always starts with a ticket just like this. A user is getting frustrated, and hey, who can blame them? 8 seconds? That's practically an eternity for a web page to load. And now it's your job to figure out what's going on. So you do your due diligence, you escalate it, and you get that classic response back, right? The database is fine. But is it really? That's what we're here to figure out. I'm going to walk you through a super simple process to gather the hard evidence you need to pinpoint the real culprit and know exactly what fix to ask for.
Okay, first things first. Before we even think about running a single query, we have to talk about safety. We need to be absolutely sure that we can investigate a live system without, making things a whole lot worse.
This really is the golden rule, right? Do no harm. Our investigation has to be completely non-destructive. We're just there to observe and diagnose, not to change any data or mess with live operations. And the good news is there are several layers of protection we can use to make sure of that.
So the absolute best and safest way to do this? Connect directly to a read-only replica. It's basically a copy of the production database where it's physically impossible for you to write any data. Now, if you don't have a replica, don't worry. The next best thing is to use a dedicated user account that only has select permissions. It can only read data. And as a final safety net, MySQL Workbench has this awesome built-in safe updates mode that'll stop you from accidentally running a huge deleter update. Honestly, if you can use all of these, you're in great shape.
All right, so we've got our safe connection. Now the real investigation can begin. Our first step is to try and understand how the database actually thinks. And to do that, we need to look at something called its execution plan.
The easiest way to think about an execution plan is like a roadmap, or maybe GPS directions for your query. See, when you ask the database for data, it doesn't just start grabbing stuff randomly. It actually comes up with a step-by-step plan to get that information in the most efficient way possible. And our first big clue is hidden right there, inside that plan.
Now, the command you typically use to see this plan is called explain, but honestly, reading its raw text output can be, well, a bit tricky. And this is exactly where MySQL Workbench becomes your best friend. It has this fantastic feature called Visual Explain. It takes that dense text-based plan and turns it into a simple color-coded flowchart. It is by far the easiest way to see what's actually happening under the hood.
So what are we actually looking for in this plan? Well, the #1 performance killer for probably 90% of slow queries is something called a full table scan. What that means is the database couldn't find a smart shortcut, an index, so its only choice is to literally read every single row in the entire table from top to bottom. Now, imagine a table with millions of rows. Yeah, you can see why that's painfully slow.
And here's the best part. This is where the diagnosis becomes super simple. You absolutely do not need to be a DBA to spot this problem. In Visual Explain, all you have to do is look for the color red. It's like a giant flashing warning sign telling you that something is being really inefficient. Yeah, think of this chart as our secret decoder ring. Each color corresponds to what's called an access type, which is just a fancy way of saying how the database is getting the data. Blue and green, those are fantastic. That means it's using an efficient index. Orange is, okay, not great, but not terrible. But red represents an access type called all, and that means a full table scan. That's our smoking gun.
Okay, so we found our big visual clue, that angry red box. This tells us what is probably making things slow. But to build a really solid case for the dev team, we need to prove exactly how slow it is. We need hard evidence.
See, here's the thing you have to remember about a standard explain plan. It's just an estimate. The database is telling you what it thinks it's going to do based on some internal statistics it keeps. But sometimes those stats are out of date, and the estimate can be way off. So we need to go beyond the estimate and get some real-world numbers. And for that, we bring out a much more powerful command, explain analyze. Now, this is different. Instead of just planning the query, this command actually runs it. It times every single step of the process and then gives you the real, actual execution data. This is what turns our suspicion from that red box into cold, hard, undeniable proof. So we take the query from that user's slow dashboard, we run explain analyze on it, and there it is, 8.2 seconds.
The actual execution time matches the user's report perfectly. We've just confirmed the problem with actual data.
All right, so think about what we've just done. We've connected the visual clue from the plan, the red box, to the hard data from the profiler. At this point, we have everything we need to build our case and propose a very specific fix.
Let's just lay out all the evidence we have. Fact 1. The visual explained clearly shows a read all node, a full table scan on the transactions table. Fact 2. We know that table is massive, over 2 million rows. Fact 3. Explain Analyze confirms that this single operation takes over 8 seconds. And finally, fact 4. We look at the query and see it's filtering by the user ID column, a column that has no index. I mean, it's a completely open and shut case.
And all of that evidence? It translates into the perfect Jira ticket. We're not just saying the dashboard is slow anymore. Now we're writing a precise, actionable request that's totally backed by data. Add an index on transactions.user_ID to fix the 8-second dashboard load. A developer is going to love a ticket like this. They can take it and fix it immediately, no questions asked.
And now for the best part, the payoff. This is the moment that makes all that investigation totally worthwhile. Getting to see the actual impact of a well-diagnosed fix. So the dev team gets our kick-it, they deploy the fix, they add that index to the user ID column, and now we go back to our safe, read-only connection inside Workbench, and we rerun our tests.
And would you look at that, 0.04 seconds. The query that was taking over 8 seconds to run is now, it's practically instant. This is a huge, huge improvement.
I mean, the difference here is just night and day. We went from 8.2 seconds all the way down to just 40 milliseconds. And if we pull up the new Visual Explain plan, that big, angry red box is gone. It's been replaced by a nice, happy green one, which tells us it's using an efficient index lookup. That is a success story you can take right back to that user and make their day.
So let's recap this whole diagnostic process. It's a really simple 4-step workflow you can use every time. Step 1, connect safely. Step 2, use Visual Explain to spot those red flags. Step 3, profile the query with Explain Analyze to get the actual timings. And Step 4, escalate with all that clear evidence for a super fast fix.
So there you have it. You now have the tools and the exact method to hunt down these kinds of performance problems. We solved the 8-second mystery, but really, this is just the beginning. The real question to ask yourself now is, what other invisible bottlenecks are hiding in your system just waiting for you to find them?